I would like to present you the project we are working on, multi-channel brain stimulation using 3-axis TMS coils integrated with a whole brain RF coil. TMS stands for transcranial magnetic stimulation. Let's think of a time-changing current passing through a coil, which produces a time-varying magnetic field. If this current passes when the coil is close to the brain, it will induce an electric field following the Maxwell-Faraday equation, trying to compensate the produced change in magnetic field. The basic idea of a multi-channel TMS system is to use a coil array to adjust and shape the induced E field by controlling the currents passed to the different elements. This concept, proposed already 20 years ago, has not been realized yet. The unique capability of a multi-channel system is that we can rapidly shift the TMS hotspot without any coil movement by purely electronic control. This opens new possibilities for brain stimulation, but it also opens many challenges. Combining TMS with fMRI has the potential to significantly increase our understanding of causal relationships between the nodes of distributed brain networks. If we look at concurrent TMS fMRI setups presently available, the standard high-density multi-channel RF coil is not an option due to the lack of space for the TMS coil. The large volume head coils with enough space for the TMS coil show unfortunately low sensitivity and no parallel imaging capabilities. None of the existing approaches enable readjusting the coil position if the subjects move the head during the scan. Our project has the potential to remove this critical barrier. The 3-axis TMS coil, just developed by our group, is used as the basic building block of the TMS array. The unit consists of 3 perpendicular coils where the X and Y element are interlaced into each other and placed over the Z element. The X and Y elements are filling the gap of the Z element, inducing a field under the center of the coil, increasing the degrees of freedom to synthesize the E fields and adding flexibility to the multi-channel array. First, the reflector trackers are placed on the subject's head, and with a pointer tracker tool, the MRI landmarks are registered with the subject's head. Secondly, the location of the 16 TMS coils are digitized with respect to head. This information is transferred into MATLAB for real-time tracking of the head movement inside the multi-channel array. This video shows how the coil positions are streamed into MATLAB, and as the subject's head moves, the coils are aligned respectively. Given a target area, the 48 TMS elements are linearly combined to synthesize the target stimulation pattern using the minimum norm estimate approach. This allocates a certain intensity to each element of the multi-channel array, and together the desired E-field pattern is achieved. Finally, the required intensities for each element are then transferred to the MagVenture rack, where coils will start firing according to a predefined stimulation pattern. This video shows the near real-time experimental setup. The localized navigator system tracks the coil position with respect to the head, and as the coil moves around the subject's head, its position is constantly streamed into MATLAB. For any coil position, the induced E field is then calculated and visualized in near real time. We designed an RF coil with holes so that the 3-axis TMS coil can go through it to enable brain stimulation. We are currently finalizing the RF coil, and we will be acquiring the first phantom MR images next month. Here, a short video how the whole system will finally look like in the scanner. It will consist of the TMS coil array, the RF coil, and the TMS holder. Thank you for your interest.